We're doing number 3 from the practice test on page 813. Just in case you want to look. Okay, so they give you that all three sides are equal to each other, so it's an equilateral triangle, which means it's equiangular as well, right? And they're asking you to find two things, okay, the perimeter and the area. Thanks. Alright, so you got to find the perimeter and you got to find the area. And they tell you the length of the side is 2A. It's not just 2, it's 2A, which is kind of weird. So that means you're going to have A as part of your answer then, aren't you? Number 3. Yes, you are. Okay, well, let's do the perimeter. The perimeter is still pretty easy. So the perimeter is just you add up all the sides. So if it's equilateral, that's 2A, that's 2A, and that's 2A, right? And so you just add them all up. What do you get when you add them all up? Just 6A, right? Okay, it's not A squared because you're adding them up. 2A plus 2A, if I have 2 of these and 2 of these, that's 4 of them, plus 2 more, that's 6 of them, so it's 6 A's. Jacob, you getting all this? Thank you. Alright, so that's the perimeter. That was pretty simple. Let's do the area, though. So you have to know a little bit of stuff to be able to find the area. Not quite as easy. Remember, it's an equilateral triangle, which means it's equiangular. If it's equiangular, what's this angle down here? That's 60, all right? And that's 60. This whole big angle up here is 60, but if I drop down a perpendicular to an equilateral triangle, it's got to be 30, so it bisects that angle up there, so that's 30. And if this whole thing is 2A, what's this little bit from here to here? That's just A. And what am I trying to find? To find the area of a triangle. 1/2 the what? The base times the height. I already know the base. What's the base of this triangle? It's 2A, right? The whole entire thing from here to here is the base, and that's 2A. Now I just have to find the height, which is the side right here. Now look, you could do trig functions if you wanted to, but let's do what we know about 30, 60, 90 triangles. First of all, what side is this on this 30, 60, 90 triangle? It's the longer side. So the longer side is equal to what? Square root of 3 times the short side. The short side is A, so what's this long side right here? Just square root of 3A. Right? That made it pretty easy, didn't it? Would you agree that knowing stuff about the 30, 60, 90, once you get used to that, does make things a lot easier? I think it does, yeah. Alright, so that's square root of 3A. So what do we do here? It's the square root of 3A. That's the height. Alright, this is the base of the whole triangle, 2A. This is the height of the triangle. Put it into the formula. Now watch. Half of 2 is just 1, so that's just A times what? The square root of 3A. Multiply them together. What is it? The square root of 3 what? A squared. And that's the area of that triangle. And that's really the best way to write it. Some people might write it A squared square root of 3. It doesn't make any difference. Either one of those is perfectly fine. Does that help? It's not so bad, is it? No. Alright, let's do another one. Alright, let's take a look at this. They give you two polygons. They tell you the length of this bottom one. They tell you the length of this. By the way, they say that they're similar parallelograms. So they do tell you that they are similar to each other. That's important. You can't just make that assumption. Alright, but they'll probably, on the test and stuff, they'll always say that it's similar. So they are similar to each other, and we want to find the area of the smaller one. So we want to find the area of this one right there. Well, we have a little formula for this. And what we do is we compare the two areas, and then we compare the squares of the corresponding sides. You hear what I say? Compare the two areas. So compare the big one to the little one. All right. So and then we compare the sides. Now, we could compare the big one to the little one, but what are we trying to solve for? The area of the what? Of the smaller one, okay? So I like to put that on top. Okay, whatever I'm trying to solve for, I just think it's easier if you just put the one you're trying to solve for on the top. So instead of comparing the big one to the small one, let's compare the small one to the big one. Is that alright with you? So I'm comparing the areas. The smaller area, which I don't know, I'll just call it A for area, over the bigger area, which is 140. Now watch, if I compare the small one to the big one, what am I going to have to do to the sides? I got to go from the small one to the big one on the side. So I go 22 to 28. But I don't just put 22 over 28 for the sides. What does the rule say? The square of the sides. Okay, so I got to take that 22 and square it, take that 28 and square that. So that's what our rule says. I think that's the last section, isn't it? Like 11.5 or something like that. All right, if you look at it, they give you a formula, but that's basically what it says. compare one area to the other. And I could have gone 140 to A, but then look where the A would have been. It would have been on the bottom. It would have taken you an extra step to solve for A. I like to put the A on the top. So I'm comparing the smaller one to the bigger one just because I want the A on the top. So I compare the smaller one to the bigger one on the sides. But I don't just compare the sides, I compare the square of the sides. Jacob, that's number 2. Strike 2, 3 strikes, you're out. Jacob. Okay, that's a foul ball. Tap him. You got to sit up. Jacob, that's 2. Okay, 3, you're done. All right, so force yourself. Thank you. So watch this. If we want to solve for A, it's one little step and we're done. How do you get rid of the 140? Multiply it by 140. Okay, that's why it's nice to put what you're trying to solve for on the top. It just makes it a lot easier if you do it that way. You don't have to. I think it just makes it easier. So now let's put this all into a calculator. Just happen to have a calculator right here. And turn it on. So it's 22 squared times 140 divided by, oops, I sure did, didn't I? Let's try that. Is that better? Divided by, why am I doing that? Boom. Oh, goodness. Oh, my gosh. Divided by, how's that? Is that better? All right, you guys are so picky. All right, 28 squared equals that right there, 86.4. So that should be this area right here, 86.4. That's the area. We'll call it 2, all right? Area of that 2 right there. That's centimeters squared. All right, yes, sir. Can I do number 4 on that worksheet? Yeah, we can give that a shot. Are we clear on that? Andre, did you get that? That was pretty simple, actually. And they're really not much different than that. Sometimes they'll tell you both areas. They'll give you one side. You got to find the other side. So one extra step for that is, like if you didn't know this side right here, it would be x squared, and then you would just have to take the square root. That's really the only thing more difficult if you have to find one of the sides. That was number 17 from that worksheet. Okay. It's page 52 on the worksheet. Okay. All right. Who? Somebody asked for another one. What was it, Travis? 4. Okay. Let's take a look at number 4. Okay. Here we go. So it's a trapezoid, and it says trapezoid too. I just said find the area, but it does say the area of the trapezoid. And here's the stuff that they give you. This side is 32, 11. Do we have a specific formula for the area of a trapezoid?
Yes.
What is that?
Base 1/2 base 1 plus base 2.
Remember, it's really close. It's really close to a triangle, isn't it? Right. Instead of 1/2 the base times the height, it's 1/2 base 1 plus base 2 because it's got 2 bases, right? Times the height. All right. So we know the 2 bases. I can see right here, 32 and 11. I'll plug them both in. I'll add them up, and then. But what don't we know that we need to find? That would be the height. So really, which one is the height here? It's that dotted line right there. That's the height because it's perpendicular. It goes from the top and it's perpendicular to the base. So any way to find that? What do you think? It is a right triangle. Okay, because that's horizontal and that's vertical. So that is a right triangle. All right, we tried this. I tried thinking with pausing the video, and I can't come up with an answer to this. I'll have to look at it on my own. And maybe sometimes when I just sit down on my own and I don't have all these eyes staring at me, I can figure it out. Or they might have left something out. They could have, but I'm not really sure. Yeah. But I don't know that. Because I don't know what that is. See, that's the key. I got to know this, or I got to know an angle. I don't think there's any way I can find any angles in here. I don't think they've given us enough information. I can't even find this rectangle because I don't know the height. Guys. So anyway, I'm at a loss to help you on that one. So obviously that will not be on the test. Okay? So I'll try that some other time, and if you're really interested, we'll take a look at it. Is there anything else on there I might be able to do? What about area of a kite, area of a rhombus? Do we remember that kind of stuff? Oh, what?
Hexagon.
hexagon number 9. Okay. So regular hexagon. Alright, so we got 6 sides. This is number 9 on the worksheet. With a side length of 15, so it's regular, so the sides are 15 centimeters. It's regular, so it means all the sides are equal to each other. And it says find the area. Alright, let's give that a shot. Now look, I don't have to draw a whole entire hexagon here. What I'm going to do is this. I'm just going to draw just a little part of it. I don't even know, well, I mean, I guess I could figure out what the angle is, but I'm just going to kind of guess. Alright, it doesn't really matter. But what I want to do is this. It says the sides are 15, so the length of that side from here to here is 15. Okay. And I want to find the area. Well, it's a regular polygon. We have a formula for the area of a regular polygon. Do you remember what that is? It's 1/2 the A. What's the little A stand for? The apothem times the perimeter. Okay, so that's what we're trying to do. Now the perimeter should be easy. Let's do that right off the bat. It's a hexagon, so how many sides is a hexagon? 6 sides. Okay, so if there's 6 sides, each side is 15. What do we do to those two numbers? 6 times 15. Okay, and what is that? 90? Okay, so we got the perimeter. So what are we really looking for here? We're looking for the apothem, aren't we? So how in the world do we find the apothem? Well, there's a couple ways to do it, but there's one way that we showed you how to do it. Let's say that's the center of the hexagon. Let's put this in a different color. What did we do? We went from the center to this vertex. We went from that center to this vertex. And we knew something. We can figure out what that angle is right there, can't we? Remember how we do that? 360 divided by 6. Okay, because there's 6 sides, there's 6 angles, right? If I kept on going, right, with all 6 of these, there'd be 6 of these. So that is what? 60 degrees. So that whole angle right there is 60 degrees. But what am I going to do? I'm not going to, I don't even have my apothem written just yet, do I? Are we listening?
Yeah.
It's a lot of talking. So I don't even have the apothem written, so let's write the apothem. That would go down like this. That blue one right there is the apothem. That's what we're trying to find. Everybody good with that? Let's go back to yellow now. Alright, so if this whole thing is 60, what's this? It's a perpendicular. This right here is a isosceles triangle, so that's got to be 30 degrees. Alright, and so this is 60 degrees. What about this side right here, from here to here? It's 7.5, right, because it's half of 15 because it bisects this other side as well. And so now we can find this. Just happens, like we did on that last problem, comes out to be a 30, 60, 90. It's not always going to do that. Sometimes you might have to use a trig function. Alright, but this one is a 30, 60, 90, so it works out kind of nice for you. So what is the apothem then? It's 7.5. We just did one just a little bit ago. Times the square root of 3. That's right, because that's the long side. This is the short side. It's just the short side times the square root of 3. So 7.5 times the square root of 3. That's the apothem. So now all we have to do is just plug it in for the area. So let's do the area. The area is 1/2 times the apothem, which is 7.5 times the square root of 3, times the perimeter, which is 90. Now, you plug all that into a calculator, and you should get the answer that they give you. Okay? I'll let you do that on your own. Everybody okay with that? I mean, that's definitely a good test question right there. Okay? I didn't draw it for you, right? They just gave it to you in words. And I didn't have to draw the whole entire hexagon. I didn't have to make sure it was all perfect. I just did it like this. Okay, it may not be exactly to scale, but all my numbers work fine like this, and I'm good to go. Yes?
To find the hypotenuse, would you just do 7.5 times 2?
Yeah, but you don't need the hypotenuse. Yeah. Yep, this is double the short side. Yep, yes.
I'm sorry, where'd you get the 90?
This 90? Because if you have a isosceles triangle and you draw, well, I drew it perpendicular on purpose because that's what the apothem is. The apothem is perpendicular to the side. Okay. Oh, this 90 right here, it's the perimeter. There's 6 sides. Each side is 15. This is 15, 15, 15, 6 times, right? So you multiply it and that's 90. Okay, so it's not 90 degrees, it's 90 centimeters, inches, whatever they give that to you. Okay? Does that help a little bit? Alright, yay, I was able to do one. I was a little disappointed after that other problem.
Sorry.
I got about 5 minutes. Is there another one they might want to do? All right, Travis. Nobody else is saying anything on that worksheet. I better be able to do it. Okay, this is pretty good. 1, 2, 3, 4, 5, 6. Oh, it's a hexagon again. All right, let's see what we have. Nah, that's good enough. You get the idea. Okay, we're running out of time. And what do? They shade some stuff in, right? So all this part right here between the circle and the hexagon is all shaded in, and that's what we're trying to find the area of. Okay, all that. Sorry, my shading's not that great because of time. So that's what we're trying to find. So basically, what are we going to do? We're going to find the area of the circle and then do what to it? Subtract the area of the hexagon. Okay? Make sense? And that's going to be the shaded region. So actually finding the shaded region isn't that big of a deal. It's just a matter of finding, what do they tell you? They tell you this right here, and they tell you that's 8. So look, finding the area of a circle is not too hard. It's pi r squared, so it's pi 8 squared minus the area of the hexagon. So really, this problem really involves finding the area of the hexagon. And this time they tell you something a little bit different, don't they? But a lot of the stuff holds true. Oops, what did I do that for? Let's try this again. Let's make this a different color. All right, watch. We're going to do the apothem. So we got to find a couple things here. This time, it's a hexagon again, isn't it? So that's kind of nice. So this is still 30. We already did that earlier. Now again, if you didn't know it was 30, 60, 90, if it was some other angles and it wasn't a special right triangle, you might have to use your trig functions, and that could very well happen on the test. I'm not really sure, but it could. All right, but in this particular situation, it works out nice. This is the short side, so it's what? It's half of 8, which is 4 right there. And what is this? This is 4 square root of 3. So now I want to find the area of the hexagon, which is 1/2 the apothem times the perimeter, correct? Now if this is 4, then what's this going to be? This is going to be 4 as well. So that's 8. So it's 8 times 6. 8 times 6 is 48. Everybody see where I got the 8 times 6? I didn't write it down because the side is 8. There's 6 sides, so 8 times 6 is 48. And then this is, well, that should be the perimeter. I'm sorry. We'll put the apothem right here, which is 4 square root of 3. I lost you. Why? I just put the perimeter first instead of the apothem. Okay? So 1/2 the perimeter times the apothem. The apothem is 4 square root of 3. And plug all those numbers in. We don't have time right now. The bell's about to ring. But put this in, subtract them, and that gives you the area of the shaded region. All right, I'm letting you hang on to that. Well, you can do whatever you want with that worksheet because I'm not collecting that. But it would be a good idea to go through some of those. All right, because this is definitely something that I could have on the test. Okay, absolutely. And 6 times 8, because the whole length of this is 8. There's 6 sides, right? See, that's 8, that's 8, that's 8. There's 6 of them. 6 8s are 48. And then this is the apothem, which is 4 square root of 3. Now again, you may not have been. You're not going to necessarily use 30, 60, 90 on every single one of these. It just happens to come out that way because they ask for hexagon. I might give you a 7-sided figure. All right, so this wouldn't be 30. It would be what? It'd be 360 divided by 7. And that's the whole thing. You take half of it, it's this. So you never know what I'm going to give you on the test.
Where's my classic chicken?